Hi. So this is what would set one questions. I am Suman. I am currently working in a top software firm, and I am optimistic and willing to learn and use new technologies for better purposes for me as well as for the companies and for betterment of human life. And that's it. I want to switch from current industry to data analytics, public data science, or data engineering, as it is increasingly used in benefit of human and businesses, and also for that it has answers to many of the questions which are currently lingering in the industry. Also, it is one of the most hottest technologies available in the market, and it offers some good pay scales as well. In the PGDDA course, I learned about different techniques, about the different tools that are used for data analysis. First is the languages like R and Python, and then we learned about the CRISP TM framework, which tells about the steps about how to prepare the data, then the EDA, then analysis, and finally the result, evaluating the data, and finally the predictions and the recommendations to be given. So I learned about predictive analytics. So I learned about the EDA, which is the exploratory data analysis. I learned about the predictive analytics. Predictive analytics means machine learning algorithms like linear regression, logistic regression, clustering, as well as SVM, naive Bayes trees, random forest, time series. Okay, and also learned a bit about big data and other stuffs. And all these algorithms are designed to give some inferences from it, from the models it builds after evaluation. My favorite project from this program is that of the HR analytics. So HR analytics, it presented with some data from the about the company who has around 4,000 employees, and about 15 to 20% of the employees face attrition every year. So it results in significant losses for the company, as it has to get new people on board, and it stalls project. Also, it has to maintain a huge HR team for the successful onboarding and offboarding of people, and other falls. So they want to decide. So they want to know about the factors which affect the attrition rate, and also they want to know about ways they should adapt to reduce the attrition rate from their company. So for this project, there were 5 datasets. So for this project, there were 5 datasets, and for that dataset, it contains data about the manager. It contains data about the employee. Uh, First data is about general information about the employee. Second data is the data which is filled by the employee himself on the work conditions. Third data is the manager data, and fourth data which is collected by some biometric system for time in and time out. From this data we can calculate the analysis. We calculated the analysis, and we calculated from these data sets. We merged the data sets, and we did some exploratory analysis to exploratory data analysis to determine on the factors on which the attrition rate depends. After that, we plotted some few graphs and to validate it. Then we did the NA treatment, that is missing values and null values treatment. We found very less amount of missing and null values, so we ignored them and we removed the rows from the dataset. After that, we did some univariate and bivariate analysis, and we found some outliers. So those outlier values also, which are above the 95th percentile mark, we also removed those values, and we got some trends from the univariate and the bivariate analysis. the univariate and bivariate analysis. So after that, under trends, we plotted, sought to use the logistic regression model, as logistic regression model is about the categorical decision making, and so what we did is we used a logistic regression model in R using GLM function, and we arrived at a model. After the initial model, we considered the high VIF values and the insignificant p values. We removed these high VIF and insignificant p values and created a new model. In this way, I created more models like that. In each step, we removed the high VIF values and the insignificant p values and arrived at the final model. So this final model, when we used on the data set, on the test data set here, so the final model when you used on the test data set, when we used on the test data set, we find that it has given the values, it has given the probabilities of that of the employees who may leave like that. But what happened is that accuracy was very high, but the sensitivity was low. So what it means that it was able to predict the people who are leaving the company, who are not leaving the company, who are staying in the company, but it is not able to predict the probability so good for employees who are leaving the company. So it is not able to predict the attrition very well. So what it happens is the accuracy is high but sensitivity is very low. So we plotted graphs for the sensitivity, accuracy and specificity, and we saw that at 0.19 value of this probability, the specificity, sensitivity and accuracy meet. So we took the optimum value as 0.19 for that, and we plotted and we calculated the probabilities. For this 0.19, we saw that the accuracy, specificity and sensitivity are both around 0.7, which is around 0.77, which is quite good. And so after that, we plotted the K statistic, we plotted the gain. The gain, as we can see that from our model in comparison to a random model, so we saw that we had gain in the third dB, so that by in the third decile we are almost able to calculate majority of the persons whom we should target for attrition. And so the gain showed us also that fact that by the maximum gain is 3 in the first decile, and when gain is 2.5 in the third decile. So the K statistic showed that we had a 53% difference in by third decile, and so we can concentrate on the employees in the first 3 decile for our attrition check. So typical steps and checkpoints in a data analytics projects are, first is data preparation. Data preparation is gathering of the data from different sources and merging them, and collection from different unstructured data and structuring them. There is data preparation. And then data cleaning. Data cleaning is part of the process where we look for missing values, NA values, outliers, wrong values, and fixing those. For most cases, if the percentage of these outliers, missing values, NA values are low, then we remove them, remove the rows containing those data, while in other cases we replace them by the mean or median. And then by the mean or median, and then we proceed to the EDA, or exploratory data analysis, so called. So EDA gives us an idea about the exploratory data analysis, which is known as EDA. Hi, sorry. So about the EDA is exploratory data analysis, where we do univariate and bivariate analysis between the dependent variable and the independent variable, and we also find the multicollinearity between the independent variables, and so this helps in checking some trends or patterns which we can get as part of those analysis. And after this analysis, we can get some characteristics of the data which is given to us. After that we proceed uh, depending on our objectives. Okay, depending on our objectives, we proceed to the data analysis part, where we will build a model using any of the linear regression techniques or logistic regression techniques or clustering like that, or other techniques. Okay, so after creating the model, we will try to get the model tuning. Okay, if this model gives a good accuracy or and specificity, then that model is good. Otherwise we will look to get new values for which the model will perform well. After that we evaluate the model on the training on the test data set, and we draw the inferences. So the last phase is the results, where we draw the results from the model and the problem statement and the solution to the problem to be addressed. Model overfitting is the case where we where the model overfitting is the case where the model is very well fitted. It gives a very good accuracy, specificity, sensitivity with the training dataset, but it does not give such good accuracy, training, and sensitivity. But it does not give such good accuracy, sensitivity, specificity with any test dataset. So what happens is there are too many dependent variables which we have to be related with the independent variable in our final model, and as a result it gives a very good accuracy for training dataset, but when it apply the same model on a test dataset, it fails as the accuracy decreases. So happens is that model is overfitting with our particular training data, and it does not mean, and that's why it doesn't work with any other unknown data as such. So that model has a high bias and a low variance, so that model is called overfitting. So this model can be very good on the training data, but it will be unable to perform so good. Its accuracy will drop considerably when used on any unknown test data. So we need a model with a high variance and a low bias, and so that model may have a less accuracy when we when we build that model with the training data set, but for any other unknown models it will give some good result. So as the overfitted model is particularly bad in case of any other unknown datasets or test datasets in case of predicting, so it is undesirable. Supervised learning and unsupervised learning. Supervised learning means for a predictive analytics, part of the predictive analytics, where there are data to support me, that is it has some inferences. Okay, so the datasets tell that how the predictive the datasets tell that give some values, give some instances of the relation between dependent and independent variables. From that we need to predict that for any other future values, how the independent variable will be related to the dependent variable. Okay, so supervised learning always has some data which is there and which can be used, and which be used to create a model, and that model for the model which will be able to predict for further future data. So supervised learning consists of linear regression and logistic regression, which always has some data, which always has some data given, which has some relation between dependent and independent variables. We need to figure it out, and we need to predict in case of any unknown model. In unsupervised learning, such as clustering, there is no concept of any relation between the dependent and independent variables. In training dataset, we are given a data and we need to cluster it according to the preferences. So we randomly choose from centroids, and we are only given about how many groups to to divide from. So unsupervised learning does not have any training data sets which it can set as reference and work. It needs to start without any reference data set, and it needs to create grouping among itself. So mainly it is used for create grouping, and how to, and not for exact prediction but for create grouping depending on consumer behavior or the data patterns. So supervised learning is like an example, given the rate of the churn of a telephone company, it has some records about customers who have churned or not churned, and from that record we need to predict whether a future customer will churn or not. We have some prices of cards which are related to some features in a market, so from that we need to calculate the price for an upcoming card with any features. So for that, from that we need to predict factors. We need to evaluate the factors on which the price of an upcoming card will depend. Supervised learning also takes into account for problems like attrition. So we have a data where we have values about attrition for a group of persons. So we need to create a model on it to evaluate if a person will do attrition or not in future on a different data set, on an unknown data set. But for unsupervised learning, it is about creating clusters. So example is there are 100 customers for a supermarket. We need to create a grouping among them based on their buying preferences, their spending capacity or their visits. So actually it is like creating 5 groups in that customer range is called clustering, so that they can be used for segmented marketing or other purposes to target their buying preferences. So on any one of the behaviors such as buying preference or the amount they spend or the number of times they visit, we need to segregate people into groups, okay, into groups as specified. So that is called unsupervised learning. An example is clustering. Missing data we need to handle if it is less in number compared to the whole data set. Then what we need to do is we can just ignore the data and we can remove the data values, the data rows from our data set. But if there are large number of missing values, we need to check what is the best approach to replace it by mean or median. Mostly we replace it by median, but again it is not a very approach because it actually causes the data to skew a bit in favor of the means, in favor of the median. So actually we should look for our higher authorities so that we can get access to the missing values data. But if anyway it is not possible, then if the number of missing values data is less, we can completely ignore them. We can replace them, we can remove those rows from our data set. But if there are a huge number of missing values, we need to replace them with the median or mean depending on situation. So in this case my expected earnings will be for $1, my expected earnings will be the probability, it will depend on the probability. So I can earn from $1 to $6 because the value of probability is from 1 to 6. So from $1 to $6 I can earn from rolling a dice. So each probability is 1 by 6. So actually I have to calculate like my probability of expected earnings is 1 by 6 into 1 square, 1 by 6 into 2 square, like that. So it is like it depends on the probability actually, what is the earning from that dice. It depends on the probability of the cumulative probability of the values which will come on turning that dice.